the recording. Here we go. So welcome to this week's Gardener review meeting. We are looking at the 1.141 release, and we have 6 topics. I will start with the systemd unit health monitor in Gardener Node Agent. Then we have Shreyas with the upgrade path for etcd 3.4 to 3.5 in the Druid. Johannes will talk about the Ingress NGINX retirement and how we are adapting Gardener. And we have Kim with the Cloud Controller Manager for load balancer support in the local setup. Alexander will talk about the Encryption Provider Types for Kube API Server. And finally, Peter, Lukas, and Niklas will guide us through the Gardener dashboard release, the latest one. Okay, then I will start with the first topic, which is about this pull request. So here we have introduced, as it said in the title, a controller that regularly checks the systemd unit health for the units on the shoot worker nodes. And this controller is part of the Gardener Node Agent. So as it's written in the description, it periodically checks the health status of the units, and then it reports a new condition, which is called systemd units ready on the nodes. And yeah, the Garden-led shoot care controller also observes this new condition. And when it's not ready, then it will be incorporated in the every node ready shoot condition. Why did we do this? So simply because we didn't have this kind of observability before. So we installed a couple of systemd units on the nodes, of course, most prominently kubelet and containerd. For them, maybe it's more obvious to see if they are not ready, because then the node will fail as on its entirety. But for other units that we have, it might not always be obvious, and we had cases where they simply failed and nobody noticed because this wasn't reported. Of course, the functionality was not working, for example, log shipping, but this you don't notice immediately or only late. And with this now we have better view of this. All right, there's also documentation here in the Gardener Node Agent documentation about the controller. But let's first go into the demo and then you will see how it works. So I have 3 panes here. I'm on the machine pod in the local setup. We have a couple of systemd units, for example, kubelet. You can see the status here. Currently it's running fine. Then here I'm watching a node, the node where I'm also SSH'd into. And as you can see, there is a new condition here that I also mentioned before, which is currently reporting everything is fine. All units that are part of the operating system config are running as expected. And finally, we watch the shoot status and the every node ready condition. And of course, also here, everything is fine. So now let's simulate the failure by simply stopping some unit, and we choose the open telemetry collector unit. So once the node agent controller checks again, which just happened, you see that this unit has, this condition has transitioned to false status because this open telemetry collector service is inactive, but it should actually be enabled. And also the Garden-led has already picked this up, and now the every node ready condition is progressing and eventually will go to a false as well, with the same explanation basically. Of course, I have tuned the intervals for the demo. So usually I think the unit check runs once a minute by default, and of course the care controller as well. If I start them again, it should quickly be resolved. So this is again true, and this is also true. That's mainly it. There's one more thing which I'm not demoing here. So if a unit is stuck in activating or deactivating for a longer period, because it maybe takes some time for whatever reason, then it only reports this as a failure as after some threshold has passed. So default is 5 minutes. So only if this situation happens for more than 5 minutes, it will be reported as false. In the meantime, the condition here should still reflect it, but the status remains true until the threshold is met. And yeah, there's in the PR, there is a bit more explanation about the very concrete health classifications. So if you're interested to read this, please check it out. Yeah, but the most important feature was this stack threshold here. All right, that's all I wanted to show. If you have any questions, feel free. Cool. Then let's continue with our second topic, which is the etcd 3.4 to 3.5 upgrade presented by Shreyas.
Hey everyone, I hope I'm audible.
Yeah.
Okay, so I'll be going through the etcd version upgrade, which was introduced in etcd-druid version 0.36.3. So why the upgrade to etcd 3.5? As of now, in Druid, we support etcd 3.4.34. etcd upstream has released etcd 3.6. Why not directly upgrade to that? Well, because the upgrade path is strictly 3.4 to 3.5 to 3.6. That's what's strictly mentioned in the docs. There are some upstream fixes which will be greatly beneficial for etcd. One of them is the fix for potential data loss in single member clusters. There's also a serializable health check endpoint support, which we can use to leverage to provide better health status reporting. Apart from that, certain methods such as the leader chain notify method has been exported, which can also be used to provide more dynamic leader relation changes reporting. Apart from that, Kubernetes version 1.31 introduced consistent list from cache, which requires a higher version of 3.4 or a version in 3.5. This is useful because this basically offloads some of the load on etcd by having a watch cache to answer some of the queries, and this can potentially improve the range queries in etcd. Moreover, etcd 3.4 is reaching the end of life with respect to upstream support, I think around the end of May or so. So hence the upgrade was necessary. So why we chose etcd 3.5.27? Well, any version below etcd 3.5.24 had a critical bug where any upgrade post that to say 3.6 or any higher version was broken. There were many issues reported where zombie members were formed and learners received corrupt membership data. And that's why we're holding on to it for a while. And the new published docs for 3.6 mention having at least 3.5.26 before upgrading, and 3.5.27 is chosen because it's the latest stable patch for this. So how we do the upgrade? So from etcd-druid, we provide a feature gate called upgrade etcd version, which is current in its alpha stage. When enabled, it takes a full snapshot as a safety net, so as to have a safety layer in case of any disaster. And this full snapshot, as you know, etcd is deployed via a stateful set. And when you reconcile the etcd resource, it's rolled, and then the version changes. This snapshot is a blocking snapshot. We have 3 attempts. In case of any failure, manual debugging has to be done. Once the snapshot succeeds, we'll roll the etcd version to the newer version. This snapshot is managed by a custom resource called etcd ops task. To give a brief context on what an ops task is, it's a custom resource we introduced a few releases back that enables etcd-druid to handle out-of-band tasks. So what are out-of-band tasks? Well, they are operations on an etcd cluster that do not modify the etcd custom resource spec. So they can include full or delta snapshots, quorum loss recovery, maintenance tasks such as defragmentation, compaction, snapshot compaction, etc. So prior to this, these processes were manual and sometimes they were multi-step processes. And there was no explicit way to track what was going on when you did these steps. So this resource basically gives a managed lifecycle for that, with various benefits such as time to live with mesh cleanup, retry mechanisms, and status tracking. Along all this with the single reconcile logic for all kind of tasks. As of now in etcd-druid, we have only implemented the on-demand full and delta snapshot, which we shall be using for the upgrade path. Now, this upgrade is not a one-way door because if there is any error once we upgrade to 3.5, there is always a fallback mechanism to 3.4, which is basically what we'll demo later on. But we do not take a full snapshot and downgrade because usually the case where we downgrade is in a disaster scenario and we do not corrupt data to be stored in the full snapshot. So this downgrade is done via a flag in the etcd config, which we pushed in the 3.4 version. Yeah, so I'll be going through a quick demo on this. As you can see, I have a local Gardener setup here with a single node, and I have one shoot. And I port forwarded etcd events and main. Let me just show. Yeah, so etcd main is running 1 GB worth of data, and it's currently at 3.4 or 34. Same for events. So the upgrade is simple as just enabling the feature gate. You will, yeah, as you can see, I've just enabled the feature gate, set that as true. Now I'll just redeploy. This will generate a new operator config, which is then picked up by our etcd-druid pod, and I'll roll the pod with the new changes once it's done. To show the old config map, as you can see, there's no feature gate set here because it was previously disabled. Should be done in a few seconds. Okay, it's done. As you can see, a new config map has been rolled up to check if it has a feature gate. Yep, it does. It's been set as true. Now let's just check if our Druid pod has rolled out. Yeah, it's been rolled like 10 seconds ago. So now upgrading is basically annotating the etcd to reconcile it. Let me just try events first. Since events does not have a backup, no full snapshot will be taken. It'll just directly be rolled. As you can see, it's rolling. While it rolls, I'll also do the same for etcd main. Since this has a backup, it'll trigger an ops task, which, as you can see, is here. And this ops task provides like the statuses of the task being run. So as of now, yeah, the snapshot is in progress. It has to take 1 GB worth of snapshot. Okay, etcd events has finished the upgrade. I can just show the etcd events has already been upgraded to 3.5.27. This is still taking the snapshot. Okay, it's done. Now the etcd main should also start rolling in some time. It has started a new pod. We port forward it and we have to wait for it to come back up. As you can see, it has also been upgraded to 3.5.27. And now let's say there is some disaster and we want to basically downgrade back to 3.4.34. That is the previous supported version. It's basically as simple as removing the feature gate. I'll just stash that and redeploy. It should do the same process again. I'll deploy the resources, redeploy our Druid pod. Okay, that's done. We should, yeah, so the new Druid pods have rolled out. Just to see the config there. No feature gate is available here, so it's gone back to the old setup. And now we just annotate the etcds again. As I mentioned, there's no snapshot taken in this scenario because this is mainly for a disaster scenario where there's something wrong that happened while we upgraded the etcd. Just wait for it to come back. Report forwarded. Let's check events first. Yeah, it's gone back to 3.4.34 and checking etcd main. Yep, that too has gone back to 3.4.34. So that's it for the demo. I hope. Are there any questions?
Apparently not. Cool. Thanks for showing this, shares.
Thank you.
And let's move on. Next up is Johannes with the Ingress NGINX retirement.
So, hello from my side. I hope you can see my screen and hear me. I'm talking about the NGINX Ingress retirement, and while etcd, as Shreyas just mentioned, or etcd-druid was ahead of the game, so before the etcd 3.4 running out of maintenance, we are with NGINX Ingress retirement a little bit after the game. So as you may know, in the Kubernetes community, there was this blog post about NGINX or Ingress NGINX retirement end of March 2026, or the retirement was end of March 2026. We're now in April, so slightly out of maintenance. And what have we done now? We have meanwhile in 1.141 basically migrated all the components in Gardener Core away from NGINX Ingress to Istio native exposure. This is the main tracking issue. It also already contains a couple of things that are not yet in 1.41, but basically the main components: Alert Manager, Dashboard, Discovery Server, Plutono, Prometheus, Vali, and the Open Telemetry Collector are now exposed via Istio native means and no longer going via NGINX Ingress. So there are a couple of PRs. If you want to go into the details, you can also find that in the issue. And just to note, the initial one, the biggest one, is the Plutono one, and then the other ones are fairly straightforward. As part of this endeavor, we've also updated the network policy controller of Gardener Resource Manager, and also updated the documentation accordingly. So as you may know, for Ingress resources, the network policy controller and Gardener Resource Manager automatically created network policies, because it's obvious that for Ingress in the Gardener context, the NGINX Ingress needs to talk to the backend denoted in the Ingress specification. And similarly, we have done now the same thing for virtual service resources of Istio, meaning that if you specify a gateway and a virtual service, you will also get corresponding network policy automatically generated by Gardener Resource Manager in a Gardener seed cluster, for example, or the Gardener runtime cluster. So, but that, with that being said, let's take a look in reality. Just quickly show what how it was before. So we're going into a 140 cluster. We see on the in the garden namespace we have a couple of Ingress resources, and in the shoot namespace, so I have a local setup with one shoot cluster here, and also in the shoot namespace you see also a couple of Ingress resources. And what is interesting to know for some of the Ingress resources, some of them like Plutono, Prometheus, and Alert Manager, they support basic authentication. So basically, if you here I have taken for the Plutono Garden for this Ingress resource, basically I'm just curling it. Then you will get, as expected, you get a 401 authentication required because I didn't specify any credentials. And now if I do a more lengthy statement and also provide the corresponding credentials from the observability Ingress secret, then you get a nice page, the Plutono page. I'm not rendering it here because it's a remote local setup. And basically the same thing happens also for the shoot cluster. I can curl it, I get the 401 authentication required. And if I do the same thing basically now with the credentials, I get the page. Now that's only the before stage. So how it worked until 140. And now with 141, that's another setup here locally running. If I look again into the garden namespace for Ingress resources, I don't see them. I also have here one shoot cluster in my local setup. And if I do the same thing basically in my shoot namespace, I also see no Ingress resources. However, if I look for virtual services, now I see a lot more. Now I see basically also that Plutono, Alert Manager, and the like are all exposed via virtual services. I can also do the same in my shoot namespace. And see there, again, I also have virtual service instances. Now, if I take one of, let's start with Plutono again, and look how, on. No, sorry, browser takes a little longer. If I just want to look at it, as usual, browser is complaining about the self-signed certificates. But if I go ahead, I see that I have the basic authentication screen. And if I copy the correct password, I can also connect to Plutono just as I could in the past, and it looks basically the same as before. Nothing special. If I do the same for the gardener, for the shoot case, that should work. Basically the same thing. Again, still self-signed certificates, and I need to copy the other credentials, and then I have Plutono also for the shoot side. So with that being said, with 141, we don't have any ingresses in Gardener Core anymore. NGINX Ingress is still deployed and available, and that is why. So the reasoning behind that is basically that we also have some extensions, some known extensions, or you might also have in your landscapes local extensions that use or that rely on NGINX Ingress. Once we have migrated all the extensions, we will also provide means, that's basically for future, to give Gardener operators the means to disable NGINX Ingress in case you don't have dependencies to it anymore, so that you can really get rid of it. Right now, basically, the Gardener core is no longer relying on it, but it's still deployed and available. And that's basically all I wanted to share. Are there any questions? Otherwise, I hand over to Tim.
Sounds good. Okay, so today I'm presenting this PR where we added the Cloud Controller Manager Local for the local setup with support for load balancers. I've worked on this with Nick for the past couple of weeks, actually. Was quite a ride, but I guess it was worth it because in the previous implementation there were a lot of hacks for implementing load balancers, and we basically had port forwards on the kind container nodes. And there was a service controller in the provider local extension which patched the services to well-known node ports that were mapped on the kind containers to the external IPs of the load balancers. So meaning this was all statically provisioned or hard-coded and only worked for specific services. So you couldn't just add another load balancer service. This was not supported. And adding new load balancer services when needed to the setup was quite the effort. And furthermore, load balancers also didn't work in shoots in the local setup. With the new implementation, all of this has been cleaned up. And instead, we have a cloud controller manager running in the kind cluster, but also in the shoot control plane. And we prepare some external IPs as loopback device aliases. You see a whole range of 32 external IPs, which can be allocated for load balancers. And the cloud controller manager running in the kind cluster or for the shoot basically mounts the Docker socket and creates additional Envoy containers that in turn have the port mappings for these external IPs. Okay, so let me show you how this looks like. So I'm targeting the kind cluster right now, and in the kube system namespace, we now see the cloud controller manager. When I create a deployment and expose it via a load balancer, we should see that this service will eventually get an external IP. So it's dynamically provisioned. This is one of the IPs on the loopback interface. So now I can curl it. Just works. If you look behind the scenes, you will find a few Docker containers with this particular load balancer label. Let's pick the one that we just created. It's the first one. We can inspect it. And here we see that this one has a port mapping from the external IP on the host's loopback interface. On this port we specified, and then Envoy will basically forward it to the node port of the kind cluster nodes. We can also look at the Envoy config to get a bit more details on that. So Envoy is basically configured with dynamic resource files so that we can add more load balancer backends, meaning new nodes when they get available, for example. But in this very simple setup, we only have one listener on port 80, and it forwards traffic to the matching cluster, so meaning the set of backends. It just forwards to this Docker container, which is my kind node, if you compare the IP. It also performs health checks, and external traffic policy local also works, but I don't want to show all of this. What you can see, however, is that there are more load balancers, like the one provisioned by Gardener Operator and the one by the Gardenlet. They also get dynamic IPs. And as we have also recently reworked the DNS setup, these IPs can then be used in the DNS records in the Bind9 server. Okay. As I told you, this also works for shoots, so let's check that out as well. I will target the shoot that I have prepared. So here we have one node. Let's create another NGINX deployment and expose it via load balancer again. Watching that should show the IP. Yeah, there we go. It's the next one in the range, and we can curl this one as well, I hope. Okay, demo gods are not with me today. Let's try that again. Create a deployment. See that it gets ready. Okay, expose it via a load balancer. Wait for that to get ready. Okay. Better. Okay, so now we should have another load balancer container in the setup. Here we do a bit more magic under the hood because the chutes nodes are not directly reachable by the Envoy container. So we add some IP routes to route the traffic via the kind nodes, and then we can also reach the chute nodes. So with all of this, we can, for the first time, access load balancers on local chutes. So a huge shout out goes out to the folks from the cloud provider Kind, so mainly Antonio from SIG Networking, because this concept was, or this idea was not ours. We just piggybacked on the idea that they have implemented for Kind. However, we implemented the Cloud Controller Manager or Cloud Provider in Gardener itself because we have a lot more scenarios than just running it for one or more kind clusters, like the chute load balancers that I just presented, but also load balancers for self-hosted chutes that might not even use kind in the future. So the idea is very similar. It's also implemented via the same cloud provider library from Kubernetes, but we have all the flexibility we need to support the Gardener scenarios. Yeah, that's it from my side.
All right. Any questions or feedback? Ben, thanks, Tim and Nick, and everybody who was involved. And we hand over to Alex for the new etcd encryption provider types.
Hello, let me just share my screen. Okay, so it should be visible now. So I'm going to present you this pair where we add these new encryption provider types for the QPAP server, the aesgcm and secretbox. These two encryption providers will be are added for the chute and garden resources, and they can be configured by end users. When someone configures them, they shouldn't have notice any difference in their chute. The only difference will be visible for operators that have access to the control plane. They'll see that the encryption configuration that is passed for the QPAP server has a different provider here, for example. And the main reason why we added this is because the current solution we had, we used aesgcm, which has had found vulnerabilities, and we wanted to improve the encryption providers used. If we go to the Kubernetes documentation, we will actually see that they have described each available provider and what are their strengths and weaknesses. The previous one was aesgcm, which is noted as weak. The two that we have added, aesgcm and secretbox, we can talk a bit about them. Secretbox is quite a new one, as mentioned here as well. It is not FIPS compliant and it is not highly recommended to configure. It is considered string, but it is not validated that well, while aesgcm is the one that we recommend. It has strong encryption. The only drawback is that it is recommended to have an auto rotation configured. In the documentation here, it is written that it must be rotated every 200,000 writes, but that is not necessarily correct because most clusters have daily more than 2000 writes. And I found a comment from the original author of this documentation, where he notes that the real limit is 2 to the power of 32. That would give clusters with 1000 writes per second around 50 days before they exceed this limitation. And for a Gartner solution, we have also added validation where you cannot enable the aesgcm encryption provider type without having configured an automatic encryption key rotation in your maintenance window. And we also now, for newly created shoots, set this rotation to 28 days. When the limit we have set for aesgcm is 90 days, you cannot have a longer period if you want to configure aesgcm. Another important note is that currently the field where you configure this provider type is immutable. That is done so that we take it in parts and we don't have some kind of mistake or bug where suddenly someone rotates to a new provider and his cluster crashes. We want to take it slow and steady and validate everything that it is working perfectly. That is from me.
Thank you, Alex. Any questions or feedback here? Also not? Okay. Then we have one more topic for today, the Gartner dashboard update, presented by Peter, Lukas, and Niklas.
Yes, thank you. I will. So we will present the changes that we did for the 184 release of the Gartner dashboard. Before I will jump into the demo part, I wanted to give a heads up regarding the next release of Gartner dashboard, where we have deprecated the Helm charts for the Gartner dashboard and the identity chart. And we plan to remove it earliest around November 2026. And the same applies for the Helm chart in the Terminal Controller Manager. All right. Then let's jump into the first topic, which is where we show a feature that we show a link to the seed Plutoner. And this is an operator feature on the shoot details page. So let's jump into one shoot. And in addition to the Plutoner link and Prometheus link, you will also have a link to the seed Plutoner as well. I cannot click on that here because this is not a fully Gartner setup, but you have to believe me. It works. Okay. All right. The next part is that we added support for seeds in the dashboard. So we have now a seed list as well as a seed details page. So this was split up into pull requests. Here on the left side, we see the seeds. And if you are an operator or have basically fewer permission on the whole landscape, you can see the seeds. So we currently limit it only to operators or landscape viewers for now. Okay, so here we see the seeds, and if the seed is a managed shoot, we also show a link where you can jump to the respective shoot resource. You can see the status as you would expect, and also the conditions. And here there is an enhancement we did. So in case the seed is a managed seed, we take the conditions of the shoot, because the seed conditions are a subset of the shoot conditions. And that's why we chose to show the conditions of the shoot, which gives more details. Yeah. And we also show the version of the seed and the Gardener version as well. And you could also opt in to show other columns like access restrictions, and if scheduling is disabled for the seed, you would see this chip, and yeah, the creation date. Okay. Then let's look at the seed details page. It looks familiar to the shoot details. You basically have the information you would expect. Here you have a link to the Plutono, and if it is a managed seed, you also have a link to the shoot Plutono and shoot Prometheus. For the, I called it here soil, which is not a managed seed. This one only has the Plutono link. You also have the Garden CTL copy button to copy the command to target the seed. And you also here have the YAML view, as you also have it on the shoot page. This is it from the seeds, and then we have also added a feature so that also landscape viewers can see the target control plane button. So when we go to a shoot, as an operator, you have, of course, the target cluster commands visible, and as well as the target control plane. But in the past, a landscape viewer could not see the target control plane button. But as a viewer or a landscape viewer, if you have the permission to create shoot viewer cube config, then it also makes sense to display the target control plane button. And then in this case, Garden login will fall back to the viewer cube config, and you can access then the seed. So let's log out here and log in as viewer, landscape viewer. I copy. So I have set up a service account and gave it permission to see all shoots across all namespaces, and this service account also has the permission to create shoots viewer cube configs. And to demo it, that's why I go via the service account way and copy it just for demo purposes. Okay, I log in. And let's go to shoot. And then we also see, I'm not an operator, but I can see all projects, I can see all shoots, and also have the target control plane button available. All right, and the last one is about the Gravatar feature that we have. So here in the upper right corner on your avatar, in the past we always fetched the Gravatar or the icon from Gravatar service, but with this feature, you are now able, as a landscape administrator, to disable it globally for the whole dashboard instance. Currently, you can only set Gravatar or none, and this is what I will do now. Let's move this one here. This is my dashboard configuration, the front-end configuration, and as avatar source, I use none now. Then I have to restart my server. Okay. Go back here. I will reload, and then a placeholder should be displayed here in the upper right corner. Yes. And that's basically it from my side. Any questions? And if not, I would hand over to Lucas, who would present updates to DNS credential handling and vendor branding.
Yeah, okay, let me share my screen. Okay. So as some of you may know, we in dashboard, besides the possibility to use theming to customize colors and stuff, we also have the branding feature. And yeah, so the branding feature allows you to change things like product name or configure how the login page looks like. And what we now introduced is vendor branding. So vendor branding is basically a way to override the display name and also the icon of built-in vendors like AWS, GCP, OpenStack, and so on. And this is possible for infrastructure providers as well as DNS providers. And you can also do it for machine image vendors. And what I can show you now is in my local Gardener dashboard, I have configured some vendor branding here. And if I now create a new cluster, you see that the first infrastructure that is also pre-selected is now called Stackscape, which is basically a fictional branding for OpenStack. And you can also see that the OpenStack is now reordered to be at the top position. And how this looks like, basically, this is just a snippet from my local config. I overrode the OpenStack vendor with a new display name, an icon that is also possible to provide using the methods the same as for the other branding stuff as described in the documentation. And I set the weight to 1 to have it at the topmost position. And as you can see, I also branded Garden Linux. So if I now scroll down, you see that this also has a new icon. And this is especially, I think, useful for things like OpenStack, where you want to apply a custom, or a corporate theme or something like that. This branding is used throughout the dashboard, so also on the credentials page. You see that if I now create here, it's also on the top. Yeah. And if I press the create button, you see that everywhere where usually would OpenStack would be, it would be called now Stackscape. Yeah. Okay. So, and besides the possibility to override the display names, we also introduced default display names for all the built-in vendors. So if you now look at this page here, you see that it's called AWS, Azure, Google Cloud, and so on. And how it looked like before was this. So you see, before this Gardener dashboard release, we only showed the internal technical names of the infrastructures and not the actual display name, how it would be correctly formatted. And but as I said, you can always override all these things using dashboard configuration. Okay, so that's it for the vendor branding. And then we improved some things around DNS handling in the dashboard. So first of all, we now use the new keys for adding, or the properties for adding DNS configuration in the shoot spec. So we go now here to the DNS configuration and look how it is configured in the root YAML. You see that we now have here a credentials ref and also use the credentials property key here. And before this dashboard release, we used the old keys that look like this. So we use secret name, which is deprecated. And in your Kubernetes versions, you need to use the new keys. So we are now also supporting this. And what is also possible is to use workload identities. So if I select here Azure, you see that I have a workload identity here, but the same applies here as for the infrastructure workload identities. It's possible to use them, but it's currently not yet possible to add or edit or delete, basically manage them through the dashboard. So this will come in one of the next releases. Okay, and something I want to mention as well is the secret binding migration feature. We already released this a couple of weeks ago in a hotfix release because it was required. And this is basically a way to migrate your secret bindings, existing secret bindings, to the new credential bindings. It's all explained here in this documentation, and you see that you have a new button in the on the credentials page where you can trigger the migration, and this will basically create a new credential binding for the same secret as the existing secret binding, and then you can use this new credentials binding in your cluster and change it using a button here on the shoot details page. But it's all explained here on this page. And the last thing I want to show is that we now have the if your dashboard is a bit smaller in its size, there was always the problem that you could not access all of your readiness tags. And so as a first improvement, we now made this scrollable here. I know it's not much, but at least you are now able to access all chips here. Okay. Yeah, that's all from my side, and I think we have still some time left, so we'll hand over to Niklas with the last topic.
Yes, also like one small change from my side. Merged the pull request and now already also released it to update our robots.txt and also added the metadata tag to our dashboard to ensure that the dashboard is not automatically crawled by search engines if it's exposed to the internet. That means if your dashboard is currently findable through search engines like Google or similar, this does not take effect immediately, but over time it will. So search engines usually recrawl their indices every 6 months. We don't know like in which part of the cycle we are in, but like from basically 1 day to 6 months, everything is possible. But then this should change. Yes, if you want to have this affected immediately, you would need to connect your domain to something like Google Console or something similar, depending on the search engine, and change this manually. But if you do nothing, this will just work in half a year from now latest. Yes, that would be it from my side.
All right. Thanks, everybody. Any feedback for the dashboard topics? Nope. Okay. Then we are at the end for today. Thanks, everybody, for presenting. So next week, the Gartner Hackathon will take place. This means that our next review meeting in 2 weeks will be the regular wrap-up and summary of the achievements. And yeah, then in 3 weeks, we continue with the next Gartner release, 1.142. Okay, then thanks again for joining and have a nice time. Bye-bye.
Thanks.
See you.
Bye-bye.
Bye-bye.